Hello students, now I'll discuss refraction by lens. It's a very important. Let us draw a lens. You can draw a concave lens or a convex lens. We have taken a convex lens. Suppose the refractive index of the material of the lens is mu1, mu2 and the refractive index of the surrounding medium is say mu1. Refractive index of surrounding medium is mu1 and suppose mu2 is greater than mu1, that is, this is denser medium, this is rarer medium. An object is placed here, okay, in the rarer medium. So light travels like this. This is the incident ray that will be refracted by this surface, that is traveling from rarer to denser medium. So it will suffer refraction. Okay, so after refraction we know that it will not move straight, it will bend towards normal. Why? Because light is traveling from rarer to denser medium, so it will move towards normal. So it should go like this, and falls image somewhere here. Okay, it is a straight line. It should go like this, it's a straight line. Fine, but it will not go like this, because after this is again rarer medium, this is denser medium, but after this here it will suffer again, another refraction. The light will suffer another refraction at the surface. Now it is traveling from denser to rarer medium. So since it is traveling from denser to medium, it will suffer refraction that will move away from the normal. It will come here. So there are two refractions. Refraction first at surface this, let us call this as ABC. First at surface ABC and then at surface ADC. This is called as I. So this we call as I dash. Let us call this as I dash and this is I. Let me draw the diagram part by part. First draw the surface ABC, then the surface ADC, part by part. Okay, first we'll draw ABC. For surface ABC, you see O is the object, AB, this is the incident ray. Now this is the point of incidence. From point of incidence we can draw a line towards the center of curvature. Okay, and you see, so this is called the normal, then this is normal, this is the incident ray. The refracted ray will be towards the normal, it will not move straight, it will move towards the normal. It will go like this. Okay, it will move towards the normal. So this is the refracted ray, so it should go here. We call this as I dash. Why I am calling this I dash? Because this is not goes like this. It will suffer refraction again here. So I call this as I dash. This side is a rarer medium of refractive index mu1. This side is a denser medium of refractive index mu2. So for this surface I can call this as U, object distance, this as R1, radius of curvature, and this as V1, suppose, image distance for this surface. Now we apply the formula. What is the formula? Formula is mu2 by image distance, that is V1. In this case image distance is V1, image distance, minus mu1 by object distance. What is object distance here? U is the object distance, equals to mu2 minus mu1 by R1. Okay, we got the equation 1. Let us draw the second surface ADC. For the second surface ADC, you see, for the second surface ADC, this is the incident ray. So it is meeting somewhere here. So this I dash will act as the object and this is virtual object. Remember, for the second surface ADC, this is the incident ray. Let me draw it here. For the second surface ADC, this is the incident ray. Okay, so it meets somewhere here. So this we call as the object. It is a virtual object. Fine. So after refraction, it goes like this. Why it goes like this? Because this is the center now. Okay, so this is normal. The line from center to the point of incidence normal. The refracted ray will move away from the normal. it will go like this. It is a normal, it will move away from the normal. So this is the image. Let me call this as I. Now I is the final image. Let me call this distance as V. Now I dash is the object in this case, and this distance is V1. Okay, and radius of curvature is R2. Radius of curvature is R2. Now the object is in, now the is incident rays, this object is in the denser side and image is in the rarer side. Object, this is the actual ray coming, so the object is somewhere here. This is virtual object, this is not real object. Object is on this side. Which side? On the denser side. Okay, so when object is in the denser side, object lies in the denser medium, then the formula will be slightly reversed. What? How to remember? Just to remember like this, we can prove it. To remember, we'll swap the values. Mu2 will become mu1, mu1 will become mu2. Mu2 become mu1 and mu1 will become mu2. Only change is this. Okay, so we can write like this. The mu1, it was mu2, now mu1 by image distance. What is the image distance? V is the image distance. V is the image distance. V is the image distance. Now in place of mu1, I'll write mu2 here. And what is the object distance? In this case, I dash is the object, so V1 is the object distance. Okay, equals to, it was mu2 minus mu1, now it will be mu1 minus mu2 by the radius is R2. Call this as equation 2. Now adding 1 plus 2, adding these two, you will see mu2 by v1 and mu2 by v1. This is plus mu2 by v1, this is minus mu2 by v1. So they will cancel each other, and what is left? Before adding, just do one thing. Mu1 by mu2 can be written as minus mu2 by mu1. Okay, mu1 by mu2 can be written as minus mu2 by mu1. Then you add, when you add this to mu2 by v1, mu2 by v1 cancel, so you will get this mu2 by mu1 by r1 minus mu2 by mu1 r2. Then you take common. Now when you take mu1 common, we have 1 by v minus 1 by u, and you take mu2 minus mu1 common, we have 1 by r1 minus 1 by r2. Then you divide throughout by mu1. So when you divide throughout by mu1, you will get 1 by v minus 1 by u. Mu1 comes to mu2 by mu1 minus mu1 by mu1 1, 1 by r1 minus 1 by r2. And what is mu2 by mu1? Mu2 by mu1 is mu. So substitute mu here. Now if object is at infinity, then image will be at focus. So image distance will be focal length. When object is at infinity, image at focus. We know this. We'll substitute this value here. So 1 by infinity, this term will become 0, and 1 by f. This v will become f. So 1 by f minus this will become 0.